Hello, my dear students. I welcome all of you on my YouTube channel, Deepak Sabnani's YouTube channel. Let's solve this problem. This problem is asked in GATE 2016, which carries 2 marks. This is a very standard problem, and many times GATE has asked similar kind of problems. Let's solve this. Problem is given as a function is given and limit x approaches to infinity is given. Limit x approaches to infinity is given. Okay, so I'll tell you how to solve this. How to solve this by a very simple method. Okay, so when you are solving the problems which carries limit which approaches to infinity, a very simple thing you can remember that suppose a algebraic expression is given to you. Let's say x to the power 4 plus x plus 1, and let's say limit of the variable x is approaches to infinity. Infinity is a very large number. When x is approaching to a very large number, then we have to check that which term is dominating. Which term is dominating? What I mean by dominating? I mean by dominating is that what I mean is that when x become very large, actually you can see that x to the power 4 will tend to infinity much faster than x to the power 1 and x to the power 0. For example, let's say if I put 2, so I'll get 2 to the power 4 as x to the power 4. This will remain 2. This is 1. Let's say I'll put 10. 10 to the power 4. This is 10 and this is 1. Now, which is more? Obviously, 10 to the power 4 is far more than 10 and 1. So, larger one is 10 to the power 4, which is a very, very, very large, or in magnitude, 10 to the power 4 is much greater than 10 and 1. So, as x approaches to infinity, then infinity to the power 4 becomes infinity first. And these terms you can easily neglect. You can easily neglect. So when limit x tend to infinity, so you can neglect lower order terms. So you can write it as x to the power 4. Okay, now we can solve this problem. This is a very beautiful problem. So if you understand one problem like this, then you can solve many number of problems which belongs to this category. Okay, so now let's solve this. So first thing what I will do, I'm seeing a root here. So you can rationalize it. You can rationalize this. Rationalizing means, so multiply by this root plus x and divide by root plus x. Okay. So square root of x square plus x minus 1 minus x into, yes, it's now into root x square plus x minus 1 plus x into and divide by the same x square plus x minus 1 plus x. Okay, that is the rationalizing. You have divided and multiplied by the same term and limit x tend to infinity, right? Now a minus b into a plus b is a square minus b square. So this will be limit x tend to infinity root x square a minus b and a plus b, a square minus b square, that is x square plus x minus 1, that is a square minus x square minus b square, right? Divided by this term root x square plus x minus 1 plus x, right? Now you can simplify this. So this will become x square and x square we can cancel out, and this will become x limit x tend to infinity x minus 1 divided by root of x square plus x minus 1 plus x plus x, right? Now one more note, that was the first note I have given you, that whenever you are getting infinite limit, then you can always neglect the lower order terms. Second note is, what is root of x square? Many will say x. That is not correct. Root of x square is mod x, because root can never give a negative answer. Root can never give a negative answer. Root of x square is mod x. Now I'll use the first note. This is the second note. Okay. First note I told, whenever you are seeing a limit where a variable approaches to infinity, that is a very large number, you can neglect lower order terms. So from x minus 1, I can neglect 1 because x is the dominating term. So limit x tend to 0, x divided by. Now from this term, square root, you get x square plus x minus 1. So x square will be dominating. It will become infinity first. So I'm taking root of x square. But what is root of x square? X or mod x? It is mod x. It is mod x plus x. Mod x plus x. Now, how you will take mod x? Mod x again. Again, there's a third note here. Because these are very simple things. And simple things are always difficult. There's a very good phrase that simple things are always difficult. So mod x will become x when you are putting a positive term inside. Mod of 1, 1. Mod of 5, 5. Mod of 100, 100. Because mod cannot give you a negative answer. Now, if you put a negative value inside mod, minus 5. What is mod of minus 5? 5. But how? Mod of minus 5 is 5. But how you got? Actually, it will multiply by minus 1 to minus 5. Then you are getting plus 5, right? So if you are putting a negative value inside mod, you will get minus x. Okay. So now x tend to infinity, which is a very large number, very large positive number. So when you are putting a very large positive number, so x will come out as it is. So this will become limit x approaches to infinity, x divided by x, mod x become x plus x. So x plus 2x upon 2x, that is half. So answer is 1 by 2. 1 by 2 is the answer. Now suppose when they give, suppose x tend to minus infinity. If they give x tend to minus infinity, then mod x will give you minus x. Mod x will give you minus x, and this limit will not exist actually. This limit will not exist. So that's why this is a very, very important step, that what you will take out from mod x. You are taking x because you are putting a very large positive number. When x tend to minus infinity, it becomes a very large negative number. So minus x will come out. So x upon 0 will not exist. X upon 0 will not exist. So it's a very important point. So what are the outcomes of this problem? We have understood three things. One, whenever some infinite limits are given, you can always neglect lower order terms. Root of x square is mod x, not x. Root of x square is mod x, not x. And how mod x works? Whatever you are putting inside mod, if it is positive, x will as it is come out. This whatever is there, it is apple, so positive apple will come out. If you are putting a negative, something negative inside, so minus of that apple will come out. Minus of that apple will come out. So these are our learnings, right? Small learnings will always group together to a very big learning, right? So I hope you understood the solution. Thank you very much.